Hello there, Mr. Sutton here with the IM3 Honors 1-2 Extra Practice Number 2 solutions on operations and compositions of functions. For this problem, we're doing g of f of t. So essentially taking f of t, this whole f of t expression, t squared plus 3, and plugging it into the g function. So instead of writing t minus 2 for the g function, I'm going to have to write f of t minus 2, or t squared plus 3 minus 2. And then I can simplify this just by combining the 3 and the 2, so that's going to be t squared plus 1. For this problem, I'm doing f of g of a. So basically taking the g of a function, a squared minus 2a, and plugging that whole expression into the f function. The f function is basically doing something plus 3. So the something in this case is going to be the g of a function. So instead of writing a plus 3, I'm going to write all of this stuff here, a squared minus 2a plus 3. Now it's important to keep in mind that these a's are not necessarily the same a, so that's why I'm able to replace this a with another expression with a totally different configuration of a's going on. Now taking a look at what we've got here, this is fully simplified. There's no like terms to combine, so we're actually done with the problem. On this one, we're doing g of h of x. H of x is just negative 4x. That's equivalent to what h of x is. So this problem is essentially saying g of negative 4x. The g function is going to square whatever you plug into it and add 3. So instead of doing x squared plus 3, now I've got to do h of x squared plus 3. So negative 4x, the whole thing squared plus 3. Notice when I do this that I'm putting negative 4x in a parentheses. So when I square that, I'm actually squaring the negative 4 and the x to get 16x squared plus 3. And then that's as simplified as it gets, so we move on. On this one, we're doing f of g of 8. So I have to start by finding the value of g of 8, and then whatever that is, I'm going to turn around and plug that into the f function. So first, g of 8, that's going to be 8 squared plus 4 times 8. So that's 64 plus 32, which adds up to 96. So that's what g of 8 is. Now, instead of doing f of g of 8, I can think of this as f of 96. F is just going to take whatever you plug in and subtract 2. So instead of doing n minus 2, I can now do 96 minus 2, which gives me the value of 94. For this problem, we're doing g of f of 1. Let me start by finding f of 1. We have to start on the inside and work our way out. F of 1 is just going to be 3 times 1, which is just 3. So now for the g function, I'm doing g of 3. That's what the value of f of 1 was. G of 3. So that's going to be negative 4 times 3 minus 2. So this 3 got plugged in here. And then just combining things, adding things up, we've got negative 12 minus 2 to give us negative 14. For this problem, I've got h of g of 5 going on. So before I can find h, I need to find g of 5 first, so that I know what I'm actually plugging into the h function. G of 5 just takes 5 and plugs it into this g function here. So 4n minus 1 is now going to be 4 times 5 minus 1. So that's just 20 minus 1, which is 19. Which means h of g of 5 really means h of 19. The h function is pretty simple. We're just doing something plus 4. So now we're going to be doing 19 plus 4, which is 23.